In this tutorial video, I'll show you how to do differential expression across synthetic subclusters. So grouping subclusters in arbitrary combinations and then computing differential expression across those combinations to find particular markers. And for this tutorial, I'll focus again on the frontal cortex dataset on cluster number 1, which are the complexin synperin positive presumed CG-derived interneurons here. So we're looking now, again, there's no genes, but there's a frontal cortex limited by neurons, limited by cluster, just cluster number 1, so we can focus on that. And if we want to look at just the subclusters within one, we can click to the subclusters tab, and we'll see here all of the subclusters that we identified within cluster 1. So for you can see that the way I've derived a name for this subcluster is through the expression pattern of two genes, synperin and complexin 3. And so if I wanted just to see how those two markers break up these clusters into groups, I can go into the gene tab and I'll type in complexin 3. And then I'll type in synporin, okay? And when I do this, you can see that complexin 3 is highly enriched in these clusters here, whereas synperin is reciprocally enriched in the other set of clusters as well. Okay? So I just wanted to show you that I'm going to use these two markers to compare this group of interneurons, the complexin 3 positive interneurons, versus the synperin positive interneurons. Okay, and I'll show you how I do that here. So I'm going to go into the clusters tab, and I'm going to click on this box which says allow target comparisons across metagroups, right? And this allows us to build synthetic groups of subclusters. And now what I'm going to do is for our target cluster, I'm going to click on all the subclusters that are marked by complexin. So that's all of them, okay? And then for a comparison now, I'm going to just letting the plot render here. Now I'm going to select every time I select a new one, it's comparing the results on the fly, so I'm obviously building, quite a collection here. But we're almost there. I'm just going to drink some coffee, as usual. Okay. So now we've created a kind of meta comparison between a target subcluster set, which are all complexin 3 positive, and a comparison set that are all synperin positive. Now if we go to the scatterplot function, we can see the results of that differential expression analysis. So you can see complexin here, obviously enriched in the complexin group, and synperin enriched in the synperin group. We can also look at other genes, for example, that are in our target group, which in this case are the complexin 3 positive interneurons. And so, for example, if I want to figure out where NDNF is expressed, again, I can click on the button and figure it out there. So that's how you build synthetic combinations of subclusters to compare through the scatter function.